Hello. So basically, now this is for 217 and teaching like the first concept, I guess, of like week one. I don't really know what this is, like this subject called. I guess we just call it ADC measurements, whatnot. But this is to teach at least me in the future if I forget or anyone else who needs this. So yeah. So basically, before we start even hopping into these questions, I kind of want to explain how this works, right? So let's say we have there's like three sections in this part, right? So we're gonna draw these three boxes to represent them. So we have the sensor, then we have the ADC, and then we have the output. Excuse my handwriting. I'm drawing on mouse, so it might not be that good. But basically, it kind of goes like this, right? So this first section is basically the input, right? Whatever this sensor reads, right? So we're gonna put this as input. And the sensor has a sensitivity, which then when it grabs the input and then it turns this input through the sensitivity, it'll turn it into a voltage, right? And then it gives it to the ADC. And then this ADC will be able to convert this voltage and then give its best estimate on it through its resolution. Resolution. And this resolution is basically um the range that it has, and then divided by the 2 to the power of n minus 1 bits, basically. And then once it takes this voltage and then through its resolution, it'll give out another voltage. And then this output will turn that voltage into a output, basically, where it's like, say this input, it's reading in G's for this example one case, it would be outputting in G, or MS squared kind of. So now that we have this fundamental understanding of this model, we can basically solve any of these questions pretty easily, right? And if you understand these words. So basically, let's solve these one by one. So we have question one, which is basically the sensor is coupled with a 10-bit ADC in the range of 0 to 7, right? And they have this measurement device which they install on the vehicle, and it measures the acceleration to be 4g constantly. So now it's asking us to calculate the difference of the sensor output and the output voltage measurement in units MV. So first, we should probably think like, what are they asking, right? So they're asking the difference of the voltage of the sensor and the difference of the voltage, or with the difference of the voltage of the ADC or the output, right? So this is what we want, right? And then we'll just put like final answer difference, right? So then now, with that, we have a range to be 0 to 7, which is just 7. Whoops, 7. And our bit is basically equal to 10 and 2 to the power of n, which is going to be, or our bit, which is actually n in this case, is going to be 2 to the power n. And let me grab a calculator. And we have 2 to the power of 10, which equals to 124 minus 1, which is 1023, right? Whoops, 1023. There you go. Okay, so now that we have all the information we need, um, we can solve this out. So basically, first off, they're saying that this input is actually 4G, right? So this 4G is going to go into the sensor, and then it's going to go through the sensitivity and make it at voltage, right? So how do we turn that into a voltage? Well, if we wanted to do that, we could do dimensional analysis to give us a easy like way to convert it. So see how the sensitivity is 76 whatever. If you just don't want to like think too much, you could use dimensional analysis. So just MV over G, and these G's actually end up canceling out. And now you get 4 times 76, which equals to 304 MV, right? So now, what does this 304 represent? This 304 represents this output voltage from the sensor, right? And then now, what happens next is that this ADC will take this voltage and put out another voltage. But how do we get this second voltage, right? Well, it's through the resolution. So how I like to think about like how this resolution works is the bigger the n, the more precise this is. And I'll try to explain it like this. So we have the big, huge bar, right? And then this is going to be the range. This whole entire area is going to represent the range. So in this case, this whole big bar, this big chunky bar, is 7 voltages, right? But then we're dividing it by whatever bit, right? So this is 1023, right? So that means that this 7 voltages is split into 1023 different, you get it, like 23 chunks, right? So then basically when we try to find the resolution, this resolution is actually this one tiny chunk that is split up into. And if we do the math, do 7 divided by 1023, we get this number. But that number is going to be in voltages since it's V over bit, right? If we're doing based off the the um the ratio here, right? But then we wanted to turn it into MV, which then we just multiply by 1000, would give us MV per bit, which is, let's see, times 1000, yeah, 6.842, whatever. So 6.842 or 3 MV. So what does this really mean? This is each chunk that is split into is this big. And if you add all these bits together, then you get 7 voltages. So now we got to see how can we get to how many chunks or these blocks, right? Can we fit or get closest to estimating this 304? It's basically how this ADC works, right? Because you only have these blocks, you can't go less or little or more. So then the best you can do with these blocks is to estimate or get as close to this number. And then how do we do that? Well, you need to find out how many blocks you need. So if we're doing a little bit dimensional analysis, we have MV, which is going to be this one, and then you multiply it by, or no, then you divide it by um the bit or by the resolution, right? And then this cancels out, and then you just get how many bits or how many blocks that you need, right? So that's what I'm going to do here. So we're going to do 304 divided by 6.843. So then we have 304 divided by 6.843, and that equals to 44. So we can't have, and this rounds down, so we only have 44 bits. And we can't, do 44.4 because we can only do in whole numbers, right? Because we can't grab half a bit or a block. So that's why we round down in this case. But if it was a 44.6 or 7, then we round up because that would be closer. In this case, it would be 44. So what does this 44 mean again? Well, it means that you need to do 44 of these chunks to get as close to as 304, in this case that we're trying to estimate, so that we can show into the output. So now we have this 44 blocks. All you just have to do is 44 multiplied by 6.843. Oops. How do we do this? 44 times 6.843, and that equals to 301. 301.092. And this is basically saying, and this is MV as well, because you have bits multiplied by MV. So now you just basically have this. So this, what does this mean? This is the voltage right here that we're trying to find. So now that we have the two voltages that we need, because we're trying to find the difference of the input and output, you just subtract these two numbers. And I'll just let you do that because I don't want to type this in. And I'm just really trying to explain for understanding. But yeah, so basically this, what the ADC does is it basically tries to estimate the voltage that it gets in through the resolution it has. And the bigger the N, the more accurate it can be. Or the smaller the range is, the more accurate it can also be in that range. So now, you'll probably also see a question, I'll probably ask somewhere down here, but I'm not going to solve these. But there's just a thing where they ask, like, what is this output? Like, what is this reading, right? And how do you convert that back? Well, you just use the sensitivity. So say if we were trying to ask, like, oh, how many G's does it show, right? Well, then you just do the voltage, 301.092, multiplied by the sensitivity, which is 76 MV over G. And wait, no, I lied. I lied so badly. You divide it, you don't multiply it. Doing a dimensional analysis. So this is in MV, and you divide it by MV over G, which is 76. And then you would get that number, whatever that number is, that would be your output. And yeah.